So hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today we have Predrag, who's the creator, maintainer, author of cargo-semver-checks. Welcome, Predrag. Do you mind to go ahead and give a quick self-introduction?
Hey, thanks for having me. So yeah, my name is Predrag. I work on cargo-semver-checks. I just really hate debugging things, and so cargo-semver-checks made a lot of sense as a tool for me to create. In summary, it's a linter for breaking changes. It makes sure that when you publish a new version of your package, it does not accidentally introduce any breaking changes you didn't mean to. It doesn't violate semantic versioning. That's something that I made as one of the first things that I built with Rust. It's been around for around 2 years, and it's been a blast working on it. So thank you so much for letting me talk about it.
I mean, I'm a huge fan of sem versioning, and we were talking before the show that you state that most people in Rust really, really care a lot about it. Not every community does. I think JavaScript is a wild west of all kinds of stuff, but that's because I think the barrier to entry is quite low, considering that JavaScript is something that so many people know, right? As opposed to Rust, which is a huge investment to just learn it, and some other languages, right? So they care a lot more about long-term software. Plus, there's a new framework every couple of days. I think nowadays is so popular. It's great that we have some kind of tool that can handle this, right? But for me as a software developer, things change all the time, right? So your tool, if I understand correctly, is supposed to be able to read the code and verify that, I guess, the version bump that you're doing is the correct one. Is that correct?
Yeah, and if it's not, then it will point out concrete things that it found that it believes are breaking changes. So it will say, you deleted this public struct, or you made this field doc hidden where it was previously public API. So every time where it finds something to complain to, it won't just say, hey, you messed up, you broke something. It will say, no, this specific change happened that is not in line with the semver bump that you attempted to just publish.
That's really interesting. So then you still can override it and say, no, what I'm doing is correct, right?
Of course, there are reasons where maintainers might want to ship a breaking change in a non-major version. That's one of the lesser known aspects of semantic versioning. So the role of the tool is to essentially make sure that the change that you're intending to make is intentional. It's not intended to tie your hands together and prevent you from doing what you think is right. It's just there as essentially a regret minimization tool, right? Once you publish a version, once everyone in the ecosystem is broken by it, you don't want to say, dang, I wish I hadn't done that. I wish something or someone had told me that I probably should take another look at this before going ahead and pushing through. And Cargo already has functionality like this, right? You've probably seen the -- allow dirty flag, which allows you to publish packages from uncommitted Git changes. Now, there are reasons why you might want to do that, and Cargo is not going to say, hey, you can't do this, please commit your changes or else I'm not doing it. But it does just make sure that you're really meant to do that and you're going into it eyes wide open.
Okay, yeah, that makes sense. Well, it's good that you can override it. I guess I could also imagine it being like a security thing where maybe you need to change something for whatever, right? Even if you do break APIs, it's better to change that in a lower version because semver people may lock it to say, don't give me the major version, which makes sense, right? And if this is a major change, could that be a possible reason why?
Oh, 100%, yes. So the way I look at semver is that it's really primarily about communication between maintainers and the users of their code and maintainers and the tooling that those users use. So in a certain situation, one could definitely imagine that the priorities of the communication are to disseminate the new version as quickly as possible, even at the expense of some breakage and some manual effort necessary. And absolutely, a sufficiently bad soundness issue or security vulnerability or something like that is definitely one of the things that they could necessitate intentionally breaking changes going into it eyes wide open. Yes, exactly. Another example is actually if you just accidentally made a piece of your library public API that you didn't intend to, right? And we've also seen this in the past that's happened, right? You make something pub and then you go, oh no, 10 minutes later, what have I done? It would really suck if now you're locked into publishing a new major version as a result of that, when in those 10 minutes, probably nobody actually updated to the new version. So you can just yank it and make that piece of your library private again. And yes, this is technically a breaking change, but again, communication over rigid norms that have no room for maintainer judgment.
We can kind of discuss what is semantic versioning, aka semver, because we have been using the shortened term of that, so people understand what we're talking about and why these things are important. Do you mind to explain?
Of course. So when we update our dependencies, most of us would do it by running cargo update, right? And that means that cargo goes and checks the registry and sees if any of our dependencies have newer versions. But it doesn't just check for any new versions, it makes sure that it updates us to only non-major versions, right? So if we're using version 1 of something, updating to 1.1 is okay, and updating to 2.0 is not something that it will do automatically. The reason it's able to do this is because of semantic versioning. Semantic versioning means that when maintainers make a change that might require user action, so it might cause breakage, it might, rework the APIs in some way that is not backwards compatible, they're expected to bump the leftmost non-zero number in their version. And if they do that, then cargo will not automatically update to that version. Any other changes can go as minor or patch versions. There's not a lot of consensus in the Rust ecosystem about which is which, so different projects do it differently. But as a rule of thumb, the most important thing is if you made a breaking change and it's not special, like we said, security issue or repairing an accidental, public API disclosure or something like that, then generally it should be a major change and not a minor change. So minor changes, cargo update should be able to update everything and everything is backwards compatible. Major changes, some human action required, cargo update will not do that automatically.
The most important part, right, is that it helps you to upgrade your packages without breaking anything, as long as people follow that standard, right?
Exactly. And so long as everything works well, we all win, right? We get new features, we get more performance, we get bug fixes, we get security patches, and all of this at a cost of, a weekly cargo update on a pull request that's configured to merge automatically after CI passes, right? So in steady state, if everything works, it's beautiful. You can have hundreds of dependencies in your project like cargo-semver-checks does, and, you just keep benefiting without really taking any manual action whatsoever. When it doesn't work, when a package accidentally bumps, the minor version, but they made a breaking change, then all of this falls apart. And it's not really just downstream users that suffer, it's actually maintainers in the entire community as well. Nobody comes out of this ahead. It's a lose-lose all around. Nobody, as a maintainer, likes to wake up in the morning and see that there's an issue with 100 comments saying, hey, you broke my project, right? And if 100 people commented, hey, you broke my project, that means that there's a lot of work that needed to happen to remediate that issue. And that is work that could have been spent in literally any other way that would have been more productive, right? Fixing bugs, adding features, improving performance, whatever. Anything except debugging why is my build broken would have been a better use of everyone's time in the community. So that's why I think adhering to semantic versioning is really important. When everyone is on the same page about how to do Semver correctly, we all win. And when not everyone is on the same page, then we all lose and everyone is worse off.
The tricky bit is like, when should we do the major bump, right? Because sometimes people do that just kind of as a kind of marking a new error, right? I just chatted with Hyper. They're at 1.2, I believe now. I talked to him. I wanted to get him on when he had 1.0 because that's a huge thing. Almost no packages in Rust go to 1.0, right? Because it's just like, there's always ever-changing APIs and people just say, well, it doesn't really matter because, what is 1.0? That's just a ceremony, right? But going to 2, I think is kind of a big deal because people start to wonder, hey, what does this actually mean? This kind of stuff. Like, for instance, I do a lot of Flutter. I think now they're at 3 dot something. But they were at, 1 dot for a long, long time. 1, I think, just marked it, okay, it's production ready. So I heard that they went to 2. I mean, this is what I heard, so don't take it as de facto standard or whatever. They went to 2 just to kind of give corporates a kind of guarantee, hey, not only is this like production ready, but it's really, really stable. We're at 2.0 now. We're in a whole new era. Come join us. That's what my understanding was. Now they're at 3 for some reason because I think they support more platforms, right? So always like the question, when should I bump my major? Because, you can just keep bumping the minor, right, for nearly forever because you're just constantly making changes over time.
Absolutely. And Cargo has an interesting tweak to the standard semantic versioning approach. Instead of just treating the leftmost number as a major version, it actually ignores leading zeros. So 0.1 to 0.2 is actually also considered a major change in Cargo. And that gives us a little bit more flexibility to reserve, like you said, with Hyper, that big version 1.0 bump for a time where it makes sense to communicate some additional information, like this is stable for a longer time than before, right? It's sort of an additional marketing angle there, as well as just, we just made some breaking changes, right? And this is why the Rust ecosystem can still benefit from tooling like cargo-semver-checks, even though, like you said, not a lot of crates actually have a 1.0 version. And in fact, cargo-semver-checks itself is also on 0.x, and it is used by other users as a library in certain tools like release please, the release manager. And so we do have Semver obligations of our own, right? And being on 0.x does not prevent us from doing that and upholding, because when we bump 0.27 to 0.28, that counts as a major version from the perspective of Cargo.
I'd like to kind of go a little bit more into, the history of this, right? Where did this come from? Was this one of those kind of spite or rage projects that you had when people weren't following semantic versioning properly?
Not quite, but I really do mean it when I say that I hate debugging. Nobody wakes up in the morning and says, gee, I'm going to really dig into some bugs today. And I did that for a job for a few years. I was a principal engineer in charge of improving developer productivity at my last job. And as a result of that, I ended up building a lot of tooling to help people not have to debug things. When a bug got found in a growing company, it's very difficult to upgrade that, hey, I found a bug, into a form of institutional knowledge, right? So that nobody else at the company will ever have to debug that bug ever again, right? That would be ideal. But if a company is growing, you're very likely to run into the same bug in 10 different places at the company within the same, 3-month period. So I built a lot of tooling to prevent these kinds of issues, and we found hundreds and hundreds of issues. I mean, it was difficult to believe how many issues we kept finding, because a bug would happen in one corner, and then we would write a lint so that it never happens again, and then we would find the same bug in 30 other places that just hadn't blown up yet. And that was a bit of a formative experience for me, because, we all know that things have bugs, but when you write a few dozen lints and you discover that the number of bugs is not in the dozens, it's actually in the hundreds, sometimes in the thousands, it's kind of terrifying. And so I was in a situation where I had some really good tooling, like the trustful query engine, which I was also using in my previous job, and semantic versioning in Rust was something that my friend Luca Palmieri pointed out to me as a big, unsolved at the time problem for the Rust ecosystem. And I said, sure, why not? I have a couple of weeks, I'll try it. Well, little did I know that there was a lot more complexity there. It turns out that Semver has a lot more edge cases than I knew at the time. But in the grand old tradition of not knowing what you're getting yourself into, I ended up building something rather cool because I didn't yet know it was hard.
I mean, you did get into it and you've gotten quite far, right? You said it's been a 2-year process, if I remember correctly?
Yeah, just about 2 years.
Did you have some specific issues that came up and you're like, all right, I'm going to start here? Did you do research to figure out what are the biggest problems that happen? Like, what was the beginning of the project like?
Yeah, I looked around at some of the options in the ecosystem, and it looked like using Rust.json was going to be the most promising avenue. So the Rust.doc tool, the same thing that powers docsrs, for example, also has an unstable mode where you can ask it to generate machine-readable JSON representation for Crates API. And that seemed ideal because it contains all the information that the abstract syntax tree doesn't. So if you wanted to ensure, for example, that some types continue implementing some auto traits, it's a lot better to ask the compiler, hey, are these traits still implemented on this type, than to attempt to infer that from regular source code. It's quite difficult to do that, bordering on impossible, so it's just much better to get this output. And as I dug into that output and saw, other folks using it, I noticed that it was, on one hand, incredibly powerful and rich, and on the other hand, would break quite often. And so a lot of the tools that used it had this issue of, the tool is great, but you're kind of forced into a specific range of nightlies that it works on, and every so often everything breaks, and you need to wait until the maintainer publishes a new version of the tool, and it doesn't really work unstable, and just a lot of little points of friction like that made life difficult for both the maintainer, who's on a shot clock to release a new version, and also in users who, didn't really want to be constrained to a specific nightly range. They just want to use stable Rust and not worry about it too hard. And so I was in a lucky position because I was able to use this trustful query engine that I mentioned to abstract away the underlying data format that everything was coming in. So even if Rust.doc's version changed, and it changed quite often, it changed on the order of once a month for, almost 18 months straight, I didn't have to do too much. We didn't have to rewrite all of the lints. It would have been absolutely unmaintainable beyond belief if we had dozens and dozens of lints, And once a month, we had to rewrite all of them because the underlying format changed. But because we were able to use this kind of extra layer of abstraction, we were able to write these lints in a declarative query language and then not worry about the format changing under the hood. We could just fix up the bindings for the format and all of the lints would continue working.
Did you have to do a lot of this kind of, yak shaving, where you end up kind of stuck on other things before you can get to the main project?
It wasn't too bad. It definitely took a bit of prototyping just to make sure that I had a handle on everything that was going on. The Rust doc format, obviously, since it has to describe anything that a Rust API can do, is fairly complex. So I honestly aimed fairly low initially. The initial versions of cargo-semver-checks could only check some basic things like, public functions that are part of your API and public structs that are in part of your API. And a lot of the more advanced lints came in later over time. So for example, we weren't able to account for things being doc hidden and therefore not part of your public API until somewhat recently when I collaborated with one of the maintainers of the PyO3 crates to add that functionality. It really wasn't trivial to figure out how, all of the edge cases of imports work and re-exports and glob re-exports and all of that stuff. Initially, the tool was quite limited, but it was pretty clear that all of these technical problems could be solved with sufficient application of yak shaving, and also the response from the community was very welcoming, which kept me motivated to keep powering through these problems. Folks who were already starting to use the tool, even when it couldn't really do a lot and it still had some teething issues like relatively slow performance and some false positives. These are issues that we've substantively solved. I'm not going to say entirely, of course, everything can always be faster and better, but they're solved enough to the point where crates like Tokyo and even Cargo itself use it, and a variety of big companies use it too, like Google and Amazon. So, if it's good enough for some of the most foundational crates in the Rust ecosystem, I think it's in pretty good shape for most Rust projects.
Your README is quite, I don't know if I want to see your word complete, but it definitely has a lot of information there about kind of the background and what it is and stuff. I was trying to understand about, you did mention in the README about cargo-semver-check versus cargo-semver-checks.
Yes. So if you publish a crate with underscores in the name, you cannot register the same name but with dashes. Crates.io denormalizes between the two essentially and just makes sure that, this is good for typo squatting attack prevention, right? So I registered cargo_semver_check and then decided that most of the Cargo plugins actually used dashes, not underscores. So dashes were the way to go. And I really tried to rename the crate cargo-semver-check. Unfortunately, I was told that's not an option. There's just no way to do it. And so it was basically underscores or plural. And so I went with the plural. So now the tool is cargo-semver-checks, plural. And the old name, I still control that package name, so it's not going to go anywhere, but it's not the tool that you're looking for.
Let's kind of talk over again about how this thing works, right? So let's say I have a brand new crate, right? So cargo-semver-checks, it wouldn't really give me any benefit to run it, but if I ran it at the beginning of the project, what would happen? Would it just say, okay, we detect that there's no version mentioned, so you can publish underneath any version number?
Yeah, it should say that, since there's nothing on crates.io, you're free to go. Right now, I think it will probably error out because it's a little bit tricky. Did the user mean to publish the very first version, which is somewhat rare, or are they just pointing at the wrong registry, right? We don't want to give you a false, you're all good, go ahead and publish kind of outcome. So we haven't sorted out the issue with the ergonomics and the user experience here, so it will probably just error right now, but it should be configurable to let you go one way or the other depending on your expectation and preferences. The tool is designed to be used right before Cargo publish right now. A lot of folks have expressed the desire to also use it in pull requests, in which case the baseline that you're comparing against should be whatever is in your main branch, right? So that will be much more useful in a fairly new project where you're still tweaking the API and you might want a second pair of eyes when you're adding some things that are going to be part of your public API and they're therefore going to require a breaking change if you publish them that way. But the biggest benefit is not necessarily if you're just starting with a project, but if your project is sort of out of the prototyping phase and some folks have already started using it. It's then that you really benefit from using cargo-semver-checks because I'm sure those folks will prefer to not be broken by an accidental breaking change. And these things happen. I mean, we all make mistakes, right? You don't really want to risk like, hey, I didn't get enough sleep this morning, or the caffeine hasn't kicked in, or I'm just not feeling very well, and now I made a mistake and I broke 100 people's projects, right? That's just not a good feeling.
So after I release my first version, whatever I want that to be, could it be 001, right? Using patch release.
Right.
So I do some changes. I want to cut a new release. Now I run cargo-semver-check, and what am I expecting to see? If something is good, if something's bad.
Right. You'll see you're all good. We ran, 60 something lints and everything passed, right? Or if you're bumping a major version, it will say, actually, all of these lints are unnecessary. I didn't even bother running them because you're bumping major anyway. And so anything is allowed, right? If it's not okay, then it will say, hey, these types compared to the same types in the previous version, they don't match, right? Or this function used to exist and it doesn't exist in the new version, so that's a breaking change. You might not want to do this, right? So for every issue that it finds, it will say the specific file, the specific, line numbers, the specific item that is the problem. It will attempt to give you enough information that you should in principle be able to even write a program that gets broken by the thing the cargo-semver-checks points out. And in fact, this is something that we used in some of our research as well, just to get a sense for Semver compliance across the Rust ecosystem.
I'm only having about 60-something checks at the moment.
Yes, although more are being added pretty much every single week. We're on an exponential growth curve, so it's a lot of fun. I mean, on one hand, it's a lot of work to continuously review these things. On the other hand, it's really amazing that a lot of people in the community are coming into the project and writing lints as their very first contribution to the project. I think that's not usual for a linter. Like, that's not the obvious place for people contribute to a new project, because these things usually require, knowledge of compilers and static analysis and things like that. But in our case, for the most part, it's community members that are contributing these lints because it's just a query and some templated error messages.
I'm just thinking, like, what if I wanted to write a custom linter, right? Does it have to be within the project in order to be run, or can I somehow attach it to be run?
Yeah, great question. That's something that I'm interested in building in the future. So if you have use cases like this, I would really love to talk to you. In principle, the underlying technology that powers cargo-semver-checks, it could run any kind of lint that you care about. And it even has the advantage that it's very easy to write lints that are designed to be easy to enable over a large legacy code base. If you've had to maintain a large legacy code base, you've probably run into the problem of, if you want to enable a new, say, Clippy lint, there are 1,000 places in the code base that don't currently adhere to that lint. And so now everything is on fire and Clippy will not let anything merge. And so your choices are either don't enable that lint or just sprinkle like 1,000 Clippy suppressions everywhere. And that's not ideal, right? It adds some friction, and so a lot of lints that maybe should have been enabled don't get enabled. Because cargo-semver-checks explicitly compares a piece of code to another piece of code, you can write lints that say, don't allow new instances of this problem to sneak in, while treating existing instances of that problem not as a reason to block a pull request, but as a thing that powers, for example, a TechDebt dashboard that you look at and you use as a burn down chart. So you can use it to set up a ratcheting mechanism where you say, no further violations of this rule. And anytime you fix a violation of that rule, it can't sneak back in. But anything that was previously broken is allowed to continue being broken until we go in and try to fix it explicitly, right? Don't block my unrelated changes over something that I didn't contribute to, that I didn't make the problem.
The reason I'm asking about the custom checker is I can imagine if you wrote a library for an API and that API changed and that's outside your control, if you could write a custom linter that would say maybe check the schema of, the easy one would be like checking the schema of like a GraphQL API, because that's very static, right? It's static in terms of you can see what functions there are, what inputs are, what stuff it takes, what stuff it needs to return. So that could be quite interesting to run. So just before the package gets released, you run the cargo-semver-check. Your custom linter says that the API change should be better, update it and maybe bump your stuff, right? That would be an interesting thing to have. I'm sure there's many other things that people would love to do, as you're just describing.
Absolutely. And there are a couple of other interesting use cases I found as well. So a lot of people don't know that when you publish a crate on crates.io, Cargo by default will include the Git hash of the repository, like of the commit from which that package was built, unless it was built from dirty Git state. in which case, it will say null because the commit hash is not meaningful, right? Because the state could have been anything. It's not necessarily reflected in the repository. Well, it turns out that with the same technology that powers cargo-semver-checks, you can run queries like find versions whose commit information as part of the published crate does not match the git tag that belongs to that version, right? Where if you go to their repo and look at where is version 1.2.3, that commit is not the commit that is published as version 1.2.3, right? And this might be an honest mistake, or it might be a sign of something nefarious that maybe a security team member should take a look at. This is something that happens way more than we would like to think. And ultimately, the improvement here is not that, suddenly a new trove of information landed in our lap that we can now take advantage of. It's instead that now that we have these kinds of tools, writing this check is easy, right? You could write it in 3 minutes and then check it in. And then, this should never be a problem again in the future. So that's really the thing that gets me really excited about the work that I'm doing. I really want to take the expertise of people and distill it into some automation so that we don't have to think about it. So that if there's something that I might want to know about a pull request, there's a piece of code that says, hey, you might want to know this, right? It's still my decision to make at the end of the day, whether I want to go through with that or not. But I don't want to say, hey, I missed this because I didn't get enough sleep or the caffeine hasn't kicked in or I've been sick for the last few days and I'm getting over it, right? These things happen. Humans are not perfect and computers can help.
In the situation of not feeling well and sick and all these things, has this happened to you quite a few times?
I was part of a study that we ran with 4 other people where we scanned the top 1,000 most popular Rust crates on Crates.io. And we found numbers that were frankly shocking and made me reevaluate how I see software development as a whole. We saw that more than 1 in 6 of those top 1,000 crates have accidentally broken semantic versioning in a way that we could have detected and prevented with cargo-semver-checks, right? More than 1 in 6. And of the 14,000 releases that we scanned, more than 3% had at least one detectable breaking change with cargo-semver-checks. These are shockingly high numbers because those are the people that are the most experienced, the most knowledgeable, the most careful, the people that know the stakes, right? The people that understand that breaking everyone in the community is not fun and it's damaging, right? And if they can't get Semver right on a day in, day out basis, there's absolutely no hope for the rest of us, right? I know I've definitely made accidental breaking changes and cargo-semver-checks has saved my bacon, right? If you go look at the publish history, you're going to find a few publishes that didn't go through, right? And so I think it's wishful thinking at this point, given the scope of data, bordering on naive to think that we're all performing at 100% all of the time, right? We kind of have the choice of we can be honest about our shortcomings and use tooling to correct for that. And we have the borrow checker and things like that in Rust already. So we're kind of well on our way, which is why I'm thrilled to be building in this ecosystem. Or we can continue to hope that everything is going to be fine and that the damage is not going to be too bad. My personal take is that hope is not a strategy, but of course your mileage may vary.
What else has kind of come to my mind as I'm thinking about developing and running these checks in CI, if you start making changes to your code and you haven't bumped the version number yet because maybe you're not quite sure how many changes until your next release, would is to start complaining, hey, you've changed, this version says like 020, 020 is already published, you've changed the APIs, you got to make a bump, we'd recommend this. Does it do something like that?
Yeah, so right now, this kind of PR-centric workflow is not the best. There are a number of crates that use it in this way. It's not the best because cargo-semver-checks can't tell the difference right now between I intend to publish this versus I'm just running this in CI. So that's something that I'm hoping to be able to build out later this year. In the meantime, you definitely could run it over CI on pull requests, and I would just recommend that you make it a non-required check and just take a look at what it found if it finds something that is a breaking change. It's not the best workflow because it will point out, hey, this is a breaking change and you haven't bumped the version exactly like you said, right? Version 2 is published. This is still version 2, so I'm treating this as a minor change, right? And you made a breaking change, so this check is going to fail, right? I'm hoping to have a much better user experience around that later this year. There are some infrastructural challenges to overcome around what does the user experience look like? Ideally, we'd like, the GitHub action to flag the specific set of lines that are the breaking change and so on. And that's proving a little bit difficult because this is one of very few linters that, like I said, looks at both the baseline code and the new code. So GitHub doesn't have the same affordances for that as it does for regular linters that just look at the new code that you intend to fix, right? Like we might want to say, hey, this public function that used to exist got deleted, but if it got deleted, then the change isn't like relative to the old code, right? In a split pull request view, it's on the left-hand side, not the right-hand side. And GitHub doesn't allow you to say, hey, the comment I want to leave is on the minus side, not on the plus side, unfortunately.
Yeah, I was just thinking, like, if you really want to promote semantic versioning, because, I mean, and when you first start off, it does take some time to get used to it and to understand. And even now, sometimes some things are debatable. We're like, is this really a .1 or is this a 1.0? Like, you know, like, am I bumping minor or patch? I don't know. Sometimes it can be on the line, right? So for the tool to say, recommend what you should do based on, you know, what the current state is and what's been published, let alone if there's a way that you could say, okay, I tend to accept what it recommends. If you can grep that out of IO, right? And then update yours and then cut the release from there, that'd be really, really nice to have. Is that something you're looking at doing?
Yes. And in particular, I think the best way to do this is by sort of meeting users where they are. So a lot of folks are using release managers like Release Please or Cargo Release. And I think it's a lot better if when users have a workflow like this, that cargo-semver-checks is made available to those release managers and then runs in the loop that way. Because, of course, you could use cargo-semver-checks to figure out if you should have bumped more than you did, right? But cargo-semver-checks, even though we keep adding more lints with every new release, it's not going to catch everything. And even if we added all of the lints that we could possibly think of, that pesky halting problem still means that you can still make breaking changes that are not going to be visible just in the APIs, right? You could change an internal implementation detail in a way that's a breaking change, but the API is still the same. So cargo-semver-checks is not ever really going to be great for saying, you know, it's okay to make this be a patch. I am 100% certain because there's some amount of human judgment that needs to go in there. But for folks that use something like conventional commits, it's very useful if the user didn't think it was a major change and the tool also doesn't think it's a major change, then everything's okay, right? And so tooling like Release Please already has this built in because you can use conventional commits to indicate whether you expect something to be breaking, and then it will pick a version number for you and it will check it with cargo-semver-checks just to be sure that, you know, nothing got missed along the way. And in that way, you know, users have the workflow that they're familiar with, and they get all of the benefits from cargo-semver-checks as well.
The other thing that comes to my mind is, what about like custom, I don't know if this is necessarily custom or what, but I often see people using RC candidates. So they'll put like 1.0.0 hyphen RC.1, this kind of stuff. Is it able to follow this? Is this actually a standard, or is this something that people just kind of have been attaching to some version?
Yes, that's a standard, and everything should work okay. So if you go from, you know, 0.9 to 1.0.0-RC1, right, that still counts as a major change. We've done a bit of work to ensure that we always pick the correct baseline version. So here's an example of something that we don't want to do, right? If you were to publish 1.0, right, the non-release candidate, we don't want to accidentally pick 1.0.0-RC1 as the baseline to compare against, right? And we also don't want to accidentally pick a yanked version as a baseline either, because you yanked it for a reason probably, right? Maybe something wasn't okay with that one, and so we should pick something else. So we were talking about yak shaving earlier. It turned out that it's actually quite a yak shave to figure out which version is the correct version for us to be checking against, right? And it's one of those things that seems like it has a correct answer, and then you go into 1,001 rabbit holes. And it turns out that all of the easy, simple to explain, you know, reasonable answers have some edge cases where they don't quite work. And so you end up with something that's like a paragraph long. But we built it, right? That's a piece of expertise that we have successfully automated. And so nobody ever has to think about this again. And I just love that feeling.
That's a great point. I totally forgot about that. I was just looking at the versions of the tool, right? The semver-checks. And I did notice you had a couple of yanked versions, right? So how do you handle yanked versions? Because technically you cannot replace that with a better version, right? If it's been yanked, that means it's actually reserved, which is unavailable to any new projects. Is that how you would say that? Because I guess Cargo would say, okay, so I guess the flow for Cargo would be something like, okay, you're at 0.1, 0.2 is yanked, so that means that if you try to do an update, it just says there's no release. If you're using 0.2 and you did an update, it wouldn't take you back to 0.1. It'd probably have a warning saying that this version's been yanked. You might want to look at upgrading as soon as possible. Is that kind of like the flow of this kind of stuff?
Yeah, that's exactly how cargo would work. There is a brand new flag, I believe. I'm not sure if it's unstable yet, but it's definitely a nightly that allows you to ask cargo to update to a yanked version on purpose. There are some very rare cases where that is the right thing to do. But yes, by default, cargo will say this version is yanked, and if it can bump you forward to a non-yanked version, it will do that. If it can bump you backward, I'm actually not sure that it will. And in the 0.2 is yanked, it will definitely not bump you to 0.1 because that's a major change, right? And so that one's completely out of bounds because it might be incompatible.
How do you handle this yanking problem? Let's just go back to the same example I had where you yanked the one, like, so it could see the yanks. So it goes probably the latest one, even though there's a yank there, but it would still report, like it would say, okay, this version, you cannot use the same version, so you need to bump something. And then it would say, but we're going to compare you to the one that wasn't yanked. Is that correct?
Yes, it will compare you to the largest numbered version that is not yanked and not a pre-release, where that version number is less than or equal to the number that you're currently on, right? So whatever number is in your cargo.toml, that version equal to or less than that, the largest version that is not yanked and not a pre-release. That's the one that we pick.
That doesn't sound so complicated. I know it's difficult to say, but it doesn't sound complicated when I think about it in my head. Or I heard that this is actually a little bit complicated.
Yeah, it's one of those things that I feel like is obvious in retrospect. Like, here's one heuristic that a few folks had brought up and that has a surprising edge case. Just pick the latest version, like the most recently published one as the baseline, right? Because it's the most recently published, so that's the one that you should compare against, right? Well, imagine if I have a library, it has version 1.2 and 1.3, right? And 1.3.1 just got released, and I want to backport it to the 1.2 series, right? So when I'm backporting to the 1.2 series, if I'm going to publish, say, 1.2.2, the correct thing to compare against is 1.2.1, not 1.3.1, even though that's the latest.
That makes sense. But now I have another one for you. We talked about Python, right? Python, I had 2.11 or something running for forever, along with 3. Something for a long time, right? You have basically two major series trees going on. Now, I'm guessing the tool must handle this, right?
For Python or for Rust?
For Rust, right? I'm talking about the idea that you have two major versions, or even maybe it's possible you have two minors that are running in parallel for some reason. You probably handle something like this, right?
Yeah, when semver-checking whichever version that you're publishing, we only look at that version, the new code that you're intending to publish, and we compare against the suitable baseline, the one we were just talking about, right? And it's okay if you have, whatever dependencies that you might have. I think it's actually one of the strengths of the Rust ecosystem that it allows multiple major versions of the same package to exist in the same workspace at the same time. And that's actually a trick that cargo-semver-checks itself uses internally. We use SERDI definitions for the Rust.json, and we just use multiple major versions of those because there's a different major version for each format of the multiple incompatible formats that we support. And so we actually rely on that trick. So of course we have to handle it correctly as well.
It sounds like you handle a lot of the edge cases I'm thinking about.
We do our best.
It's a 2-year-long project that you've been giving a lot of your time and attention to, obviously. So where is like the next step, right? Because things sound somewhat complete. I'm sure that there's always more things to do, right? What's in the pipeline for the future now?
Absolutely. One big one is having better support for that PR-centric workflow. So where we can say, these are the breaking changes relative to what's on main as opposed to what's on, in the previous version. In an ideal world, that would also allow you to do things like, for example, set a label on the pull request that says this is Semver major, so that other tooling can take advantage of that as well. Another big one is that we want to be better in the context of workspaces, where you could have complicated situations like some of the crates have not been published yet, there are internal dependencies, maybe some of the stuff is in a private registry, maybe some of the packages are not intended to be published. There are a lot of edge cases here that we want to do a really better job of, and that requires some architectural changes just to make sure that we match the user's expectations, that we offer the best possible user experience without doing something outright dangerous where we accidentally tell someone, hey, you're all good, but instead of actually checking the things they hoped that we would check, we actually checked nothing because of some unfortunate circumstance. And a huge one is actually being able to check across crate boundaries. So initially, when a crate used an item, a piece of the public API of another crate, and re-exported it itself, we relied on Rustdoc to inline that item into the Rustdoc JSON that we were seeing, and then we would check based on that. Well, unfortunately, that ended up being all sorts of problematic in Rustdoc, so it was eventually removed, but it was removed without the ability to have sort of a proper replacement. There is some information about these kinds of re-exported types, re-exported items, but it's unfortunately insufficient to resolve all of the possible edge cases that can happen, especially in the context of, like we were saying, multiple major versions happening concurrently and things like that. And so right now, cargo-semver-checks is actually, unfortunately, oblivious of these cross-crate re-exports. And that can lead to some false positives. It can lead to some false negatives. In fact, that's one of the largest categories of false positives that we have right now. And so for that, a lot of this work has to happen upstream. Folks who work on Rust and Rustdoc are aware of this. That work is happening. And as soon as there's a better mechanism available to us, I look forward to adding it as well. And this is also going to take a few months of work on my end. So I'm really hoping that I can get some funding for the project so that I can really dedicate a few months of full-time effort toward making that happen.
I'm just thinking, if somebody else doesn't follow the semantic versioning and then you re-export something out, that could also be a problem too, but you cannot really catch that, I would think, right?
Yes, and it happens all the time. It happens in very sneaky cases too. So if you re-export parts of the API, but you don't re-export everything, you might leave users in a situation where they have to guess which major version is being pulled in, and then, sort of do equality across, the two ways of getting data. It might be possible, for example, to get a type that has a field that's an enum, right? And you get a reference to that enum, but that enum is not re-exported. And so now you have to get it in some other way, right? And when you get it in that other way to pattern match on it, all of a sudden now your project has a dependency on, the re-exported crate directly and indirectly, and those two versions can diverge, and that can end up being a breaking change in itself. So yes, there are a whole bunch of edge cases there, and there are a whole bunch of best practices that I hope to write up. But ultimately, no matter how much I write about it, and no matter how much we try to be careful and avoid these kinds of issues and adhere to these best practices, without tooling, this is not going to get any better. And so in an ideal world, cargo-semver-checks would help you out here. And it would say, hey, this is risky. Here are the kinds of things that you should worry about. By the way, you should consider doing, this alternative, for example, if there's something better that you could be doing for your crate. Of course, this is all, glorious distant future kind of stuff. We don't have any concrete plans or timeline for that right now. But it's certainly within the scope of possibility, assuming that we can, solve all of the more immediate challenges that the project is seeing, like I said.
I mean, a lot of these things need a lot of work, and I also saw that you're kind of at the mercy of the API of Rustdoc, and that can and does change, right? You don't really have much control over that. So even with that, it can keep you quite busy,
Definitely. Although, as far as changes in Rustdoc go, most people, they take a look and they say, oh, so this can break more or less any time. So that must really suck. It must be a really lot of work. And so you probably don't like it when people, make these changes. Actually, I encourage the team working on Rustdoc JSON to make all of the changes that are necessary to improve the format. It's fine if it introduces a breaking change. I have the mechanisms to handle that. I even have some automation, so I can quickly port the changes that I need to make across different, Rustdoc JSON versions, and I can plug it into the trustful query engine that we use, and it's actually not that much work at the end of the day. It's something I have down. We've upgraded past something like 16 different Rustdoc versions since I started working on the tool, so it's fine. I have this down. What would be really unfortunate is if the Rustdoc JSON format stagnated and prevented the language from growing. It prevented us from having other nice things that we'd really like, right? The folks that work on Rust and Rustdoc and Rustdoc JSON in particular have a lot on their plate, right? They have to serve the entire community with all of their needs, and their needs are incredibly varied, much more varied than mine as one maintainer of one tool. And so if I can make it cheap for me to stay on the newest version and not be too bothered by these kinds of breaking changes, and it unties their hands to serve the community better, I'm all for it. So I keep telling them, if there's an improvement that you want to make and you're putting off making it because it might break the format, just go ahead and break the format. I'll adapt. It's fine. Cargo-semver-checks will keep working. I'll put in, however much work it, needs to happen. I don't want to be the bottleneck to progress here. I think that's the right mindset, Everyone wins if these tools get better, including cargo-semver-checks, including Rustock.
Yes, but if it does get worse, though, which, I mean, it's possible, but like you said, I think it's highly unlikely because so many people require this. That can also be a problem. That's probably when you would speak up and say, well, what's with this change? I'm missing these things that I need. What can we do? Has that ever happened before where you've been missing something that used to be there?
Not really. The maintainers are honestly very nice people to work with. I've really enjoyed every interaction I've had with them. And there is a nice bit of tooling in the repository that essentially it's a bot that you can ask it to ping you anytime a change that might break you could happen. So I just get tagged on any pull request that would bump the format version number. And that gives me a heads up of what's happening. And then, if I have concerns, I can voice them before that pull request gets anywhere, right? It's not going to get merged. But honestly, I think the folks that work on Rustock JSON are very smart and they're very hardworking and they're very thoughtful. So I don't think it's very likely that they're going to, make a change that is to the worst, right? I think they understand the responsibility that they've been given. And so they're very careful and cautious. And if anything, I would encourage them to break stuff more often, to advance the state of the art even faster than they have been. If that gets us more nice things quickly, I think, there are definitely aspects of Rustock JSON that with perfect 2020 hindsight, we would like to work differently, right? And so holding the format back from making those changes, I think in the long run might be more damaging. So I'm, break first, ask questions later here, at least from my perspective, right? It doesn't hurt, it only helps. And I'd much rather have all of the nice new features and be able to express things like, async and traits and things like that than to not have that information made available in Rustock as the language evolves.
Okay. Well, I think I understand quite a bit about cargo-semver-checks. So at the moment, I believe before we talked on the show, you are looking for some help, obviously, mostly in financials, right? Because you said you need, a lot of resources to keep working on this. Is that right?
Yeah, absolutely. cargo-semver-checks only happens because of all of the folks that are sponsoring me on GitHub sponsors. So I'm super thankful to everyone that's setting aside money, often from their own accounts. I very much appreciate it. But it's especially helpful when companies that benefit from cargo-semver-checks sponsor its development. And I like to think that the value that has been, put into my GitHub sponsors comes back out to the entire community because everyone is better off when these breaking changes are, not happening on a regular basis. So I would very much appreciate if your company is using cargo-semver-checks, if you could talk to them about sponsoring its development, and that will let me accelerate the pace at which I push out new functionality and fix all of the bugs that, are bothering us. I think, it's a very useful tool that a lot of people are finding value right now, but I also think that it can be 10 times better if I had, a few more months worth of development that I could dedicate to it full time rather than finding some other way to pay the bills.
No, that's good. I think the tricky part is that mostly top management, they may not really care too much about this. They're just like, well, whatever, just do this, right? It's really hard to express the value of this unless this happens so much that, you always keep delaying the releases because of this. And I guess that's the only kind of way. I'm not saying anybody should start, sabotaging internally their company in order to get this thing sponsored, but yeah, it is really tough to kind of show people the benefit of this. But I guess after a couple times you run into this, you'll definitely notice it.
Absolutely. And I think at the end of the day, it just starts by beginning to use cargo-semver-checks on projects internal to a company, right? Because it doesn't cost anything to start using it, right? But if as you use it, you find yourself wanting to have more lints, the custom lints that we were talking about, maybe some more advanced stuff that cargo-semver-checks doesn't currently do, MSRV checks, for example, or like checks of the manifest, or more complicated things that touch maybe some build-RS scripts or dependencies or things like that. All of those things are things that I would love to build, but they're only really going to be built, if I am able to find some funding. So from that perspective, I think it definitely could be a win-win. It's not just, talking to top management to sponsor tools just for the good of the ecosystem, although I do think that that is actually important, and that, some companies are much better at seeing that than, maybe others.
Well, I hope that, people can see the benefit and they start to kind of sponsor if they can. I know the economy is, some say it's good, some say it's not so good. Over here, it's not that great, but I'm hoping that things can turn around pretty soon. Again, it's great to have you on. I'm happy to hear more about this tool. I'm a huge fan of semantic versioning when people follow it. And it's interesting to see how you're doing it, using solving it with linters. And I hope that, we can pick up more funding and get more stuff done, because that'd be even better for the whole community at large. And also that could help a lot with growing the Rust community itself, I think.
Absolutely. And I really hope that, if there's just one takeaway from this entire episode, I think it should be that we all make mistakes. That's okay. That's why we have tools to save our bacon. So, I would love to get sponsorship money to dedicate more of my time to building out cargo-semver-checks. But if all you can do is just adopt cargo-semver-checks for the packages that you're publishing, that's great, right? Everyone benefits immediately, because now that means that there is one fewer breakage in, from now until the rest of time, we're all still better off, right? Everything is already nicer than it would have been otherwise.
Well, I'll definitely be taking a look at this. I think it could be something that I'd love to use in my project. So again, thank you for coming on and talking about this. And well, hopefully I'll have you again on in the future, right?
Absolutely. Thank you so much for having me. I'd love to be back anytime.
Awesome. So, hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today we have Predrag. Oh, I told you I would butcher your last name. I don't even want to try. We have Predrag, who's the creator, maintainer, author of cargo-semver-checks. Welcome, Predrag. Do you mind to go ahead and give a quick self introduction? Well, I mean, I'm a huge fan of semversioning, and we were talking before the show that you state that most people in Rust really care a lot about it. Not every community does. I think JavaScript is a wild west of all kinds of stuff, but that's because I think the entry to what do you call it? The barrier to entry is quite low, considering that JavaScript is something that so many people know, right? As opposed to Rust, which is a huge investment to just learn it, and some other languages, right? So they care a lot more about long-term software. Plus, there's a new JavaScript framework every couple of days. I think nowadays is so popular. Um, it's great that we have some kind of tool that can handle this, right? But for me as a software developer, things change all the time, right? So your tool, if I understand correctly, is supposed to be able to read the code and verify that, I guess, the version bump that you're doing is the correct one. Is that correct? Okay, that's really interesting. So then you still can override that and say, no, 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 this what I'm doing is correct, right? Okay, yeah, that makes sense. Well, it's good that you can override it because, like you said, there's things that you want that. Um, I mean, I guess I could also imagine it being like a security thing where maybe you need to change something for whatever, right? Um, Even if you do break APIs, it's better to change that in a lower version because Semver people may lock it to say, don't give me the major version, which makes sense, right? And if this is a major change, yeah, could that be a possible reason why? Yeah, sorry, I just lost something in my mind. Sorry, what I wanted to say is that we keep talking like we know what we're talking about, which we kind of do. I mean, for sure, you probably know more than me. Um, Maybe we can kind of discuss what is semantic versioning, aka semver, because we have been using the shortened term of that, and discuss, what it is. Like I said, so people can understand what we're talking about and why these things are important. Do you mind to explain? Yeah, well, that's what I think is the most important part, right? Is that it helps you to upgrade your packages without breaking anything, as long as people follow that standard, right? That's the caveat. I think the tricky bit is like when should we do the major bump, right? Because sometimes people do that just kind of as a what do you call that? Kind of marking a new era, right? I just chatted with Hyper. They're at 1.2, I believe now. Um, but I talked to him. I wanted to get him on when he had 1.0 because that's a huge thing. Almost no packages in in Rust go to 1.0, right? Because it's just like there's always ever changing APIs and people just say, well, it doesn't really matter because what is 1.0? That's just what do you call that, ceremony, right? But going to 2, I think is kind of a big deal because people start to wonder, hey, what does this actually mean? This kind of stuff. Like for instance, I do a lot of Flutter. I think now they're at 3 dot something, but they were at 1 dot for a long, long time. One I think just marked it, okay, it's production ready. And I heard that they went to 2. I mean, this is what I heard, so don't take it as what do you call it, as the de facto standard or whatever. They went to 2 just to kind of give what do you call it, corporates I say a kind of guarantee. Hey, not only is this like production ready, but it's really really stable. We're at 2.0 now. We're in a whole new era. Come join us. That's what my understanding was. Now they're at 3 for some reason because I think they support more platforms, right? It's always like the question: when should I bump my major? Because I mean, you could just keep bumping the minor, right, for nearly forever because you're just constantly making changes over time. Okay. I'd like to kind of go a little bit more into, the history of this, right? Where did this come from? Is this one of those kind of spite or rage projects that you had when people weren't following semantic versioning properly? Well, I mean, you did get into it and you've gotten quite far, right? So you said it's been a 2-year process, if I remember correctly. Okay, so I mean, I don't even know where the heck you start. Like, did you have some specific issues that came up, and you're like, all right, I'm going to start here? Did you do research to figure out what are the biggest problems that happen? Like, what was the beginning of the project like? Okay, I'm looking at this. There's a lot of. Did you do have to do a lot of this kind of what do you call it? Is it, I think it's called yak shaving, right? Where you end up kind of stuck on other things before you can get to the main project. Yeah, so I was just reading up some of your readme is quite. I don't know if I want to see your word complete, but it definitely has a lot of information there about kind of the background and what it is and stuff. I was trying to understand about. You did mention in the README about cargo-semver-check versus cargo-semver-checks. Do you mind to explain this one? I was trying to understand it. Oh, okay, I see. So let's kind of like talk over again about how this thing works, right? So, let's say I have a brand new crate, right? So cargo semver check, right? Is that how we say it? Checks. It would it wouldn't really give me any benefit to run it, but if I ran it at the beginning of the project, what would happen? I mean, would it just say, okay, we detect that there's no mentioned, so you can publish underneath any version number? Okay, so after I release my first version, whatever I want that to be, could it be 001, right? Using patch release. Uh, so I do some changes. I want to cut a new release. Now I run cargo-semver-check, and what am I expecting to see? If something is good, if something's bad. So you're only having about 60 something checks at the moment? Okay. I'm just thinking, like, what if I wanted to write a custom linter, right? Does it have to be within the project in order to be run, or can I somehow attach it to be run? Well, the reason I'm asking about the custom checker is I can imagine people, um, you know, how do I say? Like if you wrote a library for an API and that API changed and that's outside of your control, if you could write a custom linter that would say maybe check the schema of, I mean, the easy one would be like checking the schema of like a GraphQL API because that's very static, right? You can, or it's static in terms of you can see what what functions there are, what inputs there are, what stuff it takes, what stuff it needs to return. So that could be quite interesting to run. So just before the package gets released, you run the cargo-semver-check, and oh, your custom linter says that the API changed. You better, update it and maybe bump your stuff, right? That would be an interesting thing to have. I'm sure there's many other things that people would love to do, as you were just describing. You keep mentioning the situation of not feeling well and sick and all these things. Has this happened to you quite a few times?